Hi everyone, good evening. Thanks for joining in. I can still see a lot of you trickling in because it's sharp 7:30, so I'm just going to wait for everyone to join in. Yeah, by the time everyone's joining in, I'm just going to go ahead, share my screen, and we're going to get started. Hope you guys can see my screen. If you can confirm in the chat, just say yes, would be super. Awesome. Thanks, Sandeep. Thanks, Deepa. Thanks, Charan. Yes, a lot of you are saying yes. Thanks. I'm assuming you can hear me clearly. That means. Okay, let's get started. So today's topic is we're going to talk about multi-agent AI systems, building them in a production grade environment using CrewAI, right? So what goes behind that? What a production team or an engineer thinks about while going through this particular process, how do they architect that? All of that is going to be today's agenda, right? But before we get into that, I want to do a couple of things. I want to know you guys a little more. So I'm going to launch a poll and try to understand your background. What is your aspiration, career aspiration for this year? If there's something stopping you, what might that be? So that I just understand you a little better, because I'm going to come again a little later and talk about what Interview Kickstart actually does. So, having said that, some of you might know us already, and some of you might want to know a little more about us because we might be new to you. Interview Kickstart has been doing this, which is giving tech professionals customized AI up leveling and interview preparation for over 12 years. We started in the US in Santa Clara, and from there on, we have come to India in about 3 years ago. Our specialization is that we focus on outcomes. And why do we say that is because we take the pain to actually customize the AI skills and interview preparation uh, upskilling into 18 tech domains. So you could be a backend engineer, full stack, a TPM, an EM, a leader, tech leader, even a data scientist or an ML engineer. All of you will have a separate journey, right? We do that through our programs where we have about 700 plus Mang plus instructors, just like Nahid, who's the speaker for today. Pratik couldn't join in. I know Pratik was the slated speaker, but due to ill health, he had to cancel at the last moment. And Nahid has been super helpful and graceful to accept at the last minute. She works out of the US, and I'll give her introduction very quickly. But these are our secret sauce, right? Instructors are actually people who are building during their day job, building AI systems, scaling AI systems in some of the biggest names which are at the bottom of your screen, which is Amazon, Google, Anthropic, even Netflix, Atlassian, Microsoft, all of these companies, right? And over the weekends, they come and tell you exactly what they are doing and they pass on that information to you through our structured programs. I'll talk a little more about our structured programs a little later, but those programs have seen about 27,000 tech professionals already as our learners. There are certain success metrics that are in front of your screen, which is we have been able to provide top compensation about 1.7 CR INR, of course. And our instructors have, on an average, 13 years of experience. So they are highly experienced, highly specialized in what they do. And you're going to get a sneak peek into that very soon. So this was the secret sauce I was talking about, and we have about 700 of them delivering different programs in India as well as US. So the quality matches across. The audience needs are taken care of across both geographies. So getting right into it, Nahid, as I was saying, has is going to be the instructor for today's session on multi-agent AI systems with CrewAI. She, as you can see on the screen, is highly experienced. She's a principal software engineer, tech lead, and manager at Microsoft. She has over a decade of experience across Microsoft, Google, Capital One, the biggest of the names, right? Her special expertise lies in AI security and threat modeling, and she has been leading AI security, privacy, and responsible AI for Microsoft 365 Copilot product, right? So please make the most of this session. I'm going to come back a little later again to talk about our programs. But if you want to look a little beyond this masterclass and want a structured roadmap or a structured program to get the latest AI skills and interview preparation for your domain, I'm going to leave a link in the chat where you can book the calendar with our senior program advisor. With that, Nahid, welcome. Thank you for joining in, and I'm handing it over to you. Have a great session.
Yeah, absolutely. All right. Good evening, everyone. Good morning for me. Thank you so much for joining. Really appreciate it. So can you see my screen? You can hear me? Just checking. All good. Okay, perfect. Awesome. All right. So today I'm going to talk about basically multi-agent systems and CrewAI. We will begin with, some large language model fundamentals. We will learn what are agents and why and when we need multiple agents. And then we talk about CrewAI as a demo and build a three-agent system together. And then we will finish by comparing different frameworks and basically learning what we will use in production systems. And so by the end of the session, you should be able basically to answer 5 questions. What distinguishes basically an LLM from an agent? And when does basically specialization across agents improve a workflow? When is it necessary, complexity? And then what are agents, tasks, tools? What is crew? And specifically in Crew AI, we have a concept of crew. And one important question that you usually get during a lot of interviews is how does context move safely between these different stages, memory management, and then what makes the workflow fit for production. And so basically, that is the important part. Just one expectation setting is that agent is kind of like an overloaded word. Some teams use it for any LLM powered feature. Others reserve it for a system that chooses actions dynamically. And we want to have a practical, basically, definition here. Agent has a goal. Um, it observes a state and then selects, multiple actions, uses different tools or generates artifacts and repeats until it reaches a stopping condition, right? So maybe you can think about your current workflow, whether you're working or studying, and see what you have already seen, as an example where we can use an agent. For example, maybe if you're a student for coding assignment, maybe if you are working, or even, you have several products using, maybe you have used customer support services, data analysis, something like that. So think about, where you can use really agents, right? Um, the other thing is, what if your AI cloud and delegate like a senior engineer, right? So imagine, asking, a senior engineer to investigate a production incident. Like, what would they do? What differentiates them from a junior engineer? They do not personally, execute every command and read every log. They basically decompose the problem. One person examines, recent deployments, another checks infrastructure metrics. Some of them, review application traces, right? And then their main task is basically to delegate. It's valuable because it creates focused responsibilities and parallel thinking. Not because, more participants are automatically better. The senior engineer knows, when not to delegate as well, right? So basically, maybe you just need like a 5 minute configuration check that doesn't need a whole committee, right? They can immediately do it. And this is kind of like our central analogy for multi-agent orchestration. Orchestration, you are going to hear it a lot. An orchestrator identifies basically work, assigns it to a specialized role, controls information flow, and decides how the results are going to get combined with each other. There are also, layers where they enforce budget, timeout, permissions, approvals. So it brings, the whole productionalization aspect to the picture as well, right? So yeah, maybe you can think about, what is one task in your job that naturally, has a researcher, a producer, a reviewer, right? Maybe you can just put some of your answers so everyone can see, those examples. Um, just reflect on a multi-agent system. All right, so let's talk about fundamentals. We begin with the base layer, that agents do not replace LLM fundamentals. They amplify their importance. If the model is, probabilistic, then, pipeline of model calls is also probabilistic. If context is incomplete, orchestration doesn't magically, restore the truth there. So we need all of the building components of large language models still here. So basically, simplified history has four eras. The first one is basically rule based. We used to do it 10 years ago. Humans encode explicit conditions, and if, for example, if income exceeds a threshold, then make a specific, action on it, right? These systems are predictable, but they may not act good in outside of our anticipated cases, right? The second one is predictive machine learning, and instead of writing all the rules, we train a model from examples to classify, rank, predict, estimate, right? And they are, good in many cases. The third one is generative, which we have been exposed to since like 2022, almost 23. Um, Foundation models learn, broad patterns and can produce text, code, images, other content from instructions. And basically, through prompting, you can perform many tasks. And now we are in the era of agentic systems. We place a model inside a control loop with state and tools, and the system can decide, right? If it needs more information, if it calls a search API, inspecting the results, revising a plan, right? Multi-agent systems, add multiple responsibility boundaries and, some sort of coordination mechanism here. So you can think about many examples again. You do not ask an LLM whether a user is authorized if a policy engine can answer exact, right? Use the LLM, to interpret the user's intent. Then let deterministic, system to control the different permissions, right? You can think about a lot of examples, For example, a customer writes like in customer support case, I lost my phone while traveling, help me. And an LLM is useful, for recognizing the intent. For example, extracting sorry, the, the old and the new numbers, and learning that it is an urgent request. And after different verifications, it can handle some sort of ambiguous language, and then evolving, the same solution through the four eras, right? Think about how rule based would have acted, how machine learning based would have acted, how multi-agent would have acted in these different eras, right? So now we want to know how really an LLM works at high level. LLM basically is predicting a probability distribution for the next token, given the previous tokens in the context, right? Token is not always a word; it may be a word fragment. Even like when we have emphasis and we say yes, that
Hey, Nahid,
yes, yes.
sorry, very sorry to interrupt you. Your voice suddenly became very low. I don't know, something, there was a click sound and it became low. If you could just maybe move a little towards the speaker, that would be
Okay.
super helpful, and everyone's facing that.
Mhm.
So sorry for the interruption, but just wanted to,
No worries. Can you hear now?
yes. Guys, can you confirm if you can hear Nahid clearly?
You can hear. Okay. All right, perfect. So I will. Okay, now it's back. Okay, sounds good. All right, so an LLM basically predicts a probability distribution over the next token, as I mentioned, and basically calling this, an autocomplete is useful but incomplete. So maybe you can have, a tiny thought experiment. If I say the capital of France is, for example, where the distribution strongly favors, Paris as the next token. So there are three consequences that matter for agentic design. First is outputs are probabilistic, and the same request can yield, different details. Second, the model, only has the current context plus what it's training encoded, and it does not automatically know today's, internal inventory or for example this morning's accident, and then the fluent language is not proof of correctness, right? There are retrieval tools and that address some of these limitations, and instead of relying on just the model memory for example the current price, etc., we can have RAG and retrieval system. The job of the LLM is to interpret and synthesize the source system. All right. Um, Hopefully everyone can hear now. I see some confirmation on the sound. So basically we will have token prediction. And the job of the LLM is to complete the sentence for us. And also that helps with the context of explaining hallucination. When context creates pressure for a specific looking answer but does not contain enough evidence for us, the model can continue with some plausible invention, right? If we have good instructions, they basically allow us to get away from hallucination. Then we have to evaluate whether the model actually follows those instructions or not. So now let's get to some important concepts here. The first one is the model, and then we will have temperature, token, prompts, API keys. There's a lot of building components here. So the model determines the capability and the latency, the context, all of these concepts. Maybe we have to use the smallest model that reliably, satisfies the quality requirements. You can see that the market is going towards, small language models, and a lightweight model may extract fields or classify intent. A stronger model may handle complex synthesis. So it is important that your model routing considers cost, but only if your evaluation shows that it is acceptable here. Then we have temperature. Temperature basically changes, sampling behavior. If you have, a low value, generally low value for your temperature, it generally produces more concentrated text, repeatable answers, and less, innovation. And it does not turn the, truth on or off though. So a low temperature model can be, still can be confidently wrong, but it's always repeatable. If you have high temperature, it's mostly for poems and, innovation, writing purposes, etc. And token, these are the units of, model input and output. Uh, Cost and latency are often related to the amount of token that you will use. If, for example, you have a multi-agent workflow, repeated context can become, very, expensive quickly. For example, if 5 agents each receive 50-page document, you have paid, to process this document 5 times, and it is going to be very expensive. So when you think about multi-agent systems, you need to think about these concepts as well. Then we have, the prompt is more than just a user question in an agentic framework. It basically, it is assembled from system instructions, role, goal, task description, all of these. And these pieces, can conflict with each other. Usually, these events happen in production environments. And finally, we have an API key. It's basically a credential. You are already familiar with it. We used to have it in traditional software engineering as well. It's not, a configuration text, to just paste into source control or a notebook, right? You need to use environment variables locally and manage secrets, in a deployed environment. So you have to be careful really about these concepts. And two additional concepts. One is the context window, is basically the amount of material that the model can consider in a call. For example, a large window does not mean every detail, receives equal attention, right? And the other one is grounding. It means, connecting generation to relevant uh, evidence, right? Grounding reduces, unsupported claims, reduces hallucination. The final answer still needs validation, it needs citation, but we need to have groundedness in our models, right? Now, moving to, what are AI agents? Um, there's a question about how these concepts work to each other. Let me quickly, just give you a small, example here. Suppose you have a long document and it consumes 20,000 input tokens, passing it, independently to 5 agents means roughly around like 5 multiplied by 20, 100K input tokens before even counting the instructions or outputs, right? So if one and just one extraction agent converts it into 2000 token evidence artifact, then the 4 downstream agents, they don't need to consume all of those tokens. They can have, the workflow will be cheaper, it will be faster and easier even to find, groundedness. So compression, for example, is one thing that we will use in multi-agent workflows here. So about AI agents, we want to, talk about the role and goal and focus on the behavior of the agents. So basically a useful formula. Agent is equal to an LLM plus role plus goal plus tool plus a reasoning loop. And this is actually a good observation. Many times in interviews, you will be asked to design a system and you think about, okay, I'm going to call LLM models during my design, and then the interviewer asks you why not agentic platform, and you have to be able to reason why did I have goals, did I want to achieve something, did I need reasoning, right? And so we would add, state and constraints, and there are stopping conditions. Without those, it will be an infinite loop, very expensive, right? For example, a chatbot usually follows a direct, interaction, question in, answer out. An agent receives an objective such as, find a meeting time that satisfies these, specific policies, right? It may inspect calendars, it may identify conflicts, it may propose alternatives, right? And the main, like the key distinction is action, right? If code always performs search, then summary, then email, then we have an LLM enabled workflow. But if the model can decide whether search is needed, which source to query, or whether to ask for clarification, we have more agentic behavior, right? Um, and the distinction is basically between dynamic, choice and the risk, right? It's always a compromise. If it's deterministic, less risk. If it is, dynamic, then, your risk is higher, but your reward is higher, right? And multi-agent kind of like extends this idea by giving different agents separate context, separate instructions, separate tools, right? And it can improve, our focus, it can improve the evaluation system here. All right, now the anatomy of an AI agent. The first, the core loop is like perceive, reason, act, observe, repeats, right? So these are, different stages of an agent life cycle. Perceiving means receiving the user's objective, finding what is the current state, what is the relevant memory, and whether there has been any previous tool results, right? And input quality is very important in perceiving. Then we have reason. It means calling an API, querying a database, um, through an approved service, running code in a sandbox, delegating a subtask, producing, some sort of information, right? And then we have act, right? We literally run an action, right? We will call different tools. Every tool should have like a narrow contract, and your tool name, your tool description is really important. We should have, separate read-only lookups, to validate the arguments, to do schema, translation and validation, make sure that we have authentication and authorization outside the model for actions. Memory can have several meanings here. We have conversation history, right? It's basically our short-term memory. And we can have also like some sort of durable profile or previous, case index in long-term memory. We usually have a vector store that is a retrieval mechanism. It's not, some human memory. And all of the stored information, we need to define ownership for them. We need to define retention rules. We need to define freshness, all of those. We will have, planning, and it may be, explicit task decomposition, or simply, repeated next action selection. It can be simple workflow, or it can be multiple, agents kicking off at the same time. So long plans are something that you may get questions on, you need to learn, they can become stale after, the first unexpected results. So it is important that your agents can replan incrementally. And then all of these need configuration. Your model, your temperature, how many iterations, what is the number of retry, the timeout, how to delegate. Maximum iterations are safety control. You don't want to be in an infinite loop, burn all of your tokens, and return, for example, partial evidence, right? You need to be able to configure all of these events all together, right? Um, there are a lot of things that can go wrong. What if the metric tool times out? The agent should record, for example, all the missing observations, and it should move on and report that what it missed. It shouldn't just get stuck in the stage and try to repeat the same process, right? Sometimes, one agent is not enough. One agent, often, it kind of like accumulates conflicting instructions, right? And especially if it's a giant agent, right? It can be, exhaustive but brief. It can be creative, but it needs to be factual. It needs to be autonomous, but it needs to also ask for permissions. It needs to use many tools but minimize costs, right? And so its prompt becomes difficult to reason about. And when output quality drops, we don't really know what failed, what part of the system isn't working, because it's just a huge, like, giant agent, right? But if we have specialized agents, they can give us clearer boundaries. For example, a researcher agent can optimize evidence quality, writer can optimize a structure, a reviewer can test different claims and policy compliances here, right? So yeah, that is basically the reason why we move from single agent to multiple agents. So you need to use multiple agents when at least one of, these conditions are true. One is that, responsibilities, they require different instructions or different tools. Intermediate artifacts, deserve separate validation. Maybe in the middle, in the middle of your workflow you generate something, you need to make sure that it is true, because you're making the rest of your decisions based on the content of that artifact. The other thing is, tasks can run independently but in parallel. That's a pretty good motivation for using multi-agent. You would want to immediately get back to your user. um, Another situation is when security permissions are different. So you need different agents with different security boundaries, right? To do explorations. Or maybe the system needs an explicit, uh, critical role versus approval role, right? These are all conditions where we need multi-agent. And you should think of agents as some sort of service boundaries, right? Distributed systems, for example, are really powerful, but we do not create a microservice for every function, right? So we should not create an agent for every paragraph of a prompt. So we shouldn't also overdo it. We shouldn't over engineer. Same concepts transfer to multi-agent as well. Now let's move to, from individual capability to a team design, right? The quality of, the team depends less on, one job title, but more on the contracts, ownership, coordination between multiple people in the team. Same thing is applied to agentic systems as well. So orchestrator, multi-agent orchestration basically coordinates specialized agents to achieve a larger objective. The orchestrator's job is to determine the order, execution order. It needs to also provide context, what is the state of each agent. It handles failures and it also combines results, right? Maybe, we can use an example of a newsroom. You have a reporter, they gather evidence. You have a journalist, it turns evidence into a story. Then the editor, checks clarity and unsupported claims. Then you have probably a social team, that adapts the approved story to different channels, right? And each role has like a distinct definition here. So translate this analogy into contracts. The reporter needs to return claims with different source URL, publication date, confidence note. The writer accepts only the research that is returned, in a structured draft. Editor, either returns, approval or list of issues to those claims. And then social content or social media is going to, only get the approved form and advertise it. So that is basically the job of the orchestration layer. What starts the workflow, which tasks are sequential or parallel, what data can each agent see, how many, retries are we allowed to do, and it's not necessarily another LLM. Maybe it can even be, a deterministic code, it can be a workflow engine, you may have like a manager agent when there is need for decomposing an ambiguous goal, but not necessarily. It can simply be a workflow here, right? And so, why it matters now, and what breaks without it? Why do we even try to come up with these topics, and why now multi-agent is really important? Multiple reasons you can see on the slide. One is, hallucination cascading. For example, agent A invents a market statistic, agent B receives it as a context and writes an argument. Then agent C, compresses it into a confident social post, right? Each stage increases, some sort of legitimacy. So the fix is not, another reviewer agent, but we need to, provide citations. We need to validate claims against different sources. We need to prevent downstream stages without treating the previous, making sure that previous stages are valid here. So another reason, no graceful degradation, you can see. Search may be, unavailable or rate limited, the system should distinguish between no evidence exists and the evidence tool failed. It can, retry without, back off, use an approved fallback technique, and we need, silently allowing the LLM to substitute memory is often, the worst fallback here, right? Another thing is like, output format chaos, right? If one task sometimes returns bullets, sometimes JSON, sometimes an essay, right? It doesn't work for us. We need to generate stuff in a structured format. And here we need, validation that approves the shape and basic constraints. Another thing is generation versus, action. A model drafts a refund, deployment, email, social post, etc. And then the system immediately executes it. That collapses, recommendation and authorization. We should make sure that, we represent, proposed actions explicitly, run policy checks, require, approval based on risk, and then and only then, go through with the action. So you can see that is why we need multi-agent. A single agent cannot be responsible for all of these. There are a lot of other risks as well. For example, prompt injection, excessive tool permissions, um, runway loops, duplicate actions, right? So maybe you need to think about cascading failure, right? For example, a researcher finds an old blog post claiming a product has a feature, it omits the publication date, a writer converts the claim to present tense, right? All of these need to be fact checked, right? Fact checker may help, but it doesn't replace the controls that we have all over the boundaries. And if we want to control the boundaries, we need to have defense in depth. We need to separate the duties so we can control them step by step, right? So these are mostly the reasons, we have behind using multi-agent systems. So we have different orchestration patterns, how these agents really collaborate with each other. One is sequential, right? This is like what we can usually be mostly think about, A, then B, then C. It's ideal when, later work depends on earlier artifacts, and our research, writing, social pipelines follow this pattern, right? The example that we will have at the end. The second one is hierarchical. A manager, for example, decomposes the objective, assigns work to a specialist, and this is useful when subtasks cannot be known in advance. For example, open-ended investigations, right? And then the third one is parallel. Independent agents run simultaneously, and a reducer combines results. We are, assessing a vendor, for example, security, financial, legal analysis can be done separately, independently. So, and the latency, will be the latency of our slowest agent in this case, right? So we don't need to do it sequentially. It can be done in parallel. Many systems often use a directed graph, like classify the request, fan out to a specialist, merge the results, and then route low confidence cases to review and loop for, correction. You need to choose the pattern from dependencies. For example, does task B require A's result or not? Can they be done in parallel or not? If deterministic routing, is it simpler than a manager agent or not? Always, choose for simplicity, because agents' behaviors are non-deterministic, and if you overuse agents, you will not be able to fact check, you will not be able to validate your agent's results here. And then, compare, content production, right? It does the result make sense? Is it in the same order? How would, a human, process this whole events, right? So maybe you can think about different cases. For example, translating same document into 5 languages, right? um, that can be done in parallel, right? 5 languages independent from each other. Diagnosing some sort of outage, unfamiliar outage, it needs investigation, right? So it basically needs an agent deciding for us, a manager agent in between. So think about different scenarios and see whether you will go with, parallel or hierarchical or sequential cases in this case. All right, now moving to CrewAI, map the architecture into, CrewAI's vocabulary here. So what is CrewAI? Basically, CrewAI is a Python framework for role-oriented agent collaboration. Its API lets us describe agents, tasks, tools, the process connecting them. It is Pythonic and intuitive. It's important because, readable orchestration is easier to review, right? A product owner can often understand a research task, feeds a writing task, even without reading every implementation detail. It is production ready. It should always, be unpacked for us, be important for us. Built-in structured output, callbacks, retries, observability are very useful foundations, and your application still owns authentication, authorization, maybe like secret management, all of these. But it provides a lot of, production ready capabilities for us. And this tool, ecosystem kind of accelerates integration for us, but every third party tool needs to be reviewed. So in any agentic system, third party tools need to be reviewed. So for example, what network calls can this tool make? What data it sends? Does it log arguments or not? Can it mutate? So these are things that you need to verify for yourself. There are some, packages available for experiment and, straightforward cruise. If the workflow needs complex, conditional state, durable pauses for lasting days, right? Maybe many, long working agents. You may pair the agent framework with a workflow engine or choose a graph-oriented system. And then, there are framework APIs that evolve rapidly. You can isolate, framework specific code behind your own interfaces where it sounds practical for you. So it is really, great framework, especially because it's production ready. It provides a lot of capabilities for you already. So there are core building blocks. And one of them is agent. It basically combines the role, goal, model, tools, configurations. Role labels will help you, but you need concrete, instructions. For example, senior researcher is very vague, right? Versus saying, find 5 independently verifiable claims that are published within the past 12 months. Return the source, right? You can imagine how giving really specified instructions is going to be helpful. Then we have a task, and it defines work and expected output. It should state inputs, constraints, what is definition of done, what is the failure behavior, right? In mature systems, the task is the primary unit of evaluation. We always have task success rate as one of our metrics. Then we have a tool that is a capability exposed to an agent. You need to give it a narrow name. You need to have typed arguments. You need to have a clear description, and least privileges implementation. You need to validate the arguments in code, and treat, for example, web pages, documents returned by the tool as an untrusted data. The tools are one of the major security threats in an agentic system. Crew basically binds agents and tasks, and you can think of it as a configured workflow instance, and the crew should receive an identifier, right? So all the logs, all the artifacts, all the costs, all of these need to be associated with a crew ID. And then we have a process, and it defines, control flow, whether it's sequential or hierarchical. It determines who runs when and how context moves between your different agents. And let's have a design example. For example, let's say for invoice handling, right? You can have an extraction agent that reads the invoice, a validation task, right? Compares total and your purchase order fields, and an exception, task prepares a review case here. You can have like a payment API. It should not be a general tool, available to all of your agents or sub-agents. After you validate and after you approve, you need to have like a deterministic executor that performs that payment. And it should probably have an idempotency key, because you don't want to have, double payments. You don't want to have two charges, right? And you can think about which agent owns validation, what is the schema, what evidence do we retain. Like, if evals and evaluations are really hot topics right now, by the way. So now design patterns for CrewAI. We have context chaining. You pass selected previous outputs into a task, and the word selected here is crucial, because more context is not always better, right? You need to do maybe compression, just pass the information that it needs. This reduces your costs, right? And leakage, and reduces distraction. You need to have a structured output. You use, a pedantic model or some sort of equivalent schema here. For example, a research item can have claim, source URL, publish that, and, maybe evidence. We can require exactly 5 items and non-empty, requirements. You need to do schema validation, and it cannot, the schema validation cannot prove the source supports the claim. So we need to also add semantic checks, right, to review what risks how much risk can we afford to have. Then you need to have temperature tuning. You should follow, task characteristics. Maybe, for example, extraction and compliance check need consistency. maybe creative alternatives, tolerate higher temperature levels. And do not assume that every agent needs its own model setting, right? Establish some sort of baseline through evaluations. You will have conditional loops, for example, supporting graceful configuration. If a search credential is absent in a workshop, then the demo might operate on supplied resources, right? In production, make sure to have fallback behavior very explicit, right? You need to have delegation control, keeping responsibilities clear. If the workflow is already sequential, allowing every agent to delegate may create hidden paths or unpredictable costs. And observability is what separates a senior engineer from a junior engineer. Always have observability as part of your design process. You should capture the run IDs, task an agent, the model, the latency, their token usage. All of these need to be captured, and you should be very careful with verbose logs. Prompts and tool results may contain sensitive data, credentials, confidential content. You need to have, redaction strategies built into your whole process. Right, so yeah, the context change, like we can dig in much deeper into each of these contents. For example, context chaining should pass, a structured assessment. But we will move, to the example to walk through an example of the demo later. Then we have, when we want to take it to production environment, these are, the most important notes to consider. One is secret management. You never, hard code your credentials. Local environment variables may be acceptable for development, but deployed system should use managed secret service workload identity, right? Scoping the credentials to minimum operation, right? The other one is telemetry control. Decide what is logged before, turning on verbose tracing. Redact secrets and sensitive fields. Separate development from production telemetry. Retention policy for your logs. The other one is output persistence. You need to save those structured artifacts with their metadata, schema version, and this supports audits later, pre-processing, reprocessing, regression analysis. And you need to also avoid persisting everything, indefinitely. You need to have some sort of data minimization, data deletion requirement here. Human in the loop is a topic that is discussed often in many interviews. You need to match approval to consequence. A draft blog post may need, editorial approval. Low value internal recommendation may only need sampling. So sometimes you need to bring in human, to approve something. Especially, for example, think about production systems in medical fields, in financial fields. Human review sometimes is needed. It's not useful if the reviewer sees no evidence, right, and is overwhelmed by alerts. So you need to also carefully design this human in the loop process. The other one is error handling, categorizing, failures. For example, 429 error response deserves some sort of backoff, right? Invalid structured output may deserve to get, one constraint repair attempt, right? Authentication failure should stop immediately. Missing evidence should return insufficient evidence. Think about your error handling. And then environment, verification, right? Checking supported Python versions, validating credentials without exposing them. Readiness checks in deployed, services include health checks, but do not call, costly models for every probe, right? So basically, you can think about all of these steps as part of your design. Every, practical release path has different stages. You need to have offline evaluation. You need to go into shadow mode where you can observe real inputs, but its outputs are not shown or acted upon. You can have, assisted mode, users see drafts and approve them. Maybe if you have like a low risk, well measured action, they may eventually become automated. Then you will do quality monitoring to detect drift, tracking your schema failures, all of those errors. You need to have incident response as part of the process, provide a kill switch for your tool execution, a way to revoke credentials, right? Some way to quarantine your affected runs here. So all of like what we have learned in traditional software engineer translates into multi-agent systems as well. All right. Just quickly checking the question box. Okay.
Now, there are some questions in the Q&A section. If you
Oh,
want,
okay.
I've
I
left a
see.
few. Yeah, I've left a few for you. You can maybe pick some of them right now and answer.
Okay,
Sure.
perfect. Let me check open. Um, all right, temperature, little confusing, repeating again. Temperature is basically, so when your large language model generates predictable tokens, it basically gives them a probability, right? If you set temperature to really low values, it's always going to pick the highest probable next token. So there is no room for innovation. It always keeps saying that, capital of France is Paris. But if you set temperature to a higher value, it has room for more innovation, and it can even choose some, tokens that don't have the highest probability. So it may generate the capital of Paris is the beautiful romantic, the capital of France is the beautiful romantic Paris, right? So you can see with high temperature, there is room for novelty and some sort of like generation of text that is more non-deterministic compared to lower temperature. All right, so this one is answered. Cost can increase if we don't choose the specific agents with a good understanding. How to achieve? I don't quite get it, but I think you want to discuss, um, how can we manage, cost between different agents? There are multiple things that you need to consider. What sort of task you are assigning to them, the task complexity, whether it needs reasoning, whether you have a couple of few short examples for that task or not. So depending on that, you will choose maybe a small language model, you may choose a base model. Sometimes you decide, to fine tune a small language model for yourself, for your specific case, and that is helpful for your cost. Another consideration is that do you want to host your own fine-tuned model, or do you just want to pay for tokens? So how to achieve that is usually by, designing constraints that you're exposed to depending on your problem. We usually start with, smaller, lower costly models. At the evaluation stage, we will see if those models are meeting our requirements in terms of success metrics. And then if not, then we will move to more costly models. I hope that answers your question. Scenarios for parallel. For example, I can say about my own use case. We build, some support engineering multi-agent system, and there are different sources that, that agentic system needs to, search for: knowledge base, guidelines, searching the code. These are independent of each other, and we kick off all of these agents at the same time. Each of them go and do their task, and they come back with the results, and then we merge all of them all together. What are examples of tools? Good question. For example, web search. Or the most popular example of tools that I have seen is that many traditional companies actually have their own legacy code. and they want to now agentify their whole system. So they transform their legacy code, their legacy functions into tools. Maybe you can think about an accounting, for example, software company, and they have a way to calculate the tax for a specific case for a specific business. That tax calculation function can become a tool. That mathematical, that formula part can become a tool in this case. All right, so I feel like I think I will be moving with the presentation if that's okay, and then I'll go back to questions again. I want to make sure that we get to our demo as well. Um,
Certainly. Thanks.
yeah. Sure. So what can you build? Basically, the examples can be in terms of product, program management, software engineering, engineering management. This is what we discuss in all classes. Multi-agent is actually have made the different fields have a little bit of overlap, right? So, for example, competitive, intelligence crew can retrieve approved sources, extract claims. It should label, source dates, avoid presenting absence of evidence. Maybe you have a bug triage crew and they can classify, this is what I have in my job. They can classify a report, search similar issues, inspect different logs, and maybe incident post-mortem system can build a timeline from the logs, the tickets, find gaps, root cause of the errors. Um, there are multiple examples. So when you are selecting your first project, choose some sort of high frequency text heavy work with accessible evidence and then reversible outputs. It is important that you choose a project that is meaningful, and LLM it will be really good at solving it. For example, drafting and recommendation are safer starting points than some sort of autonomous external action. So define a baseline. How long does the current process take? What error happens? What quality threshold must the new system meet? And then, move to building your first system. And after that, of course, you can, there's room for always for improvement here. All right, we want to get to our demo. Let me, just go over the problem statement. We want to design a concrete crew. And so our input is a topic, agentic analytics for data analytics. Our desired output is 5, research insights, some structured article, and, social media drafts, depending on the platform. Why don't we ask one model to do everything, right? Research rewards, current evidence, precision, source discipline. Then we have article writing. We need coherent structure and explanation. Then we need social media editing. It needs a strict length. Maybe Twitter used to be like 140 characters. Maybe it needs a specific tone for example, X versus LinkedIn. And we need platform conventions. So the objectives can conflict. For example, article needs to be long, social media needs to be short, right? So before we write code, we define some sort of acceptance criteria. We will say research must contain 5 non-duplicate claims and sources. Article must only use supported claims, right? Social drafts must preserve meaning, must satisfy platform constraints. And we also need to define what is, out of scope behavior. If live search is unavailable, then the system either uses a supplied source pack and labels that mode or stops. It must not, claim that, remembered model knowledge is live search, right? So it's an excellent place to establish a baseline. We need to run a single agent prompt on 10 topics and score it, then compare the multi-agent design for groundedness, format validity, latency, and costs, right? um, All right, so now we have three agents here. One is the research analyst. It has a narrow goal, producing five source-backed insights. A low temperature here supports consistency. The search tool provides current evidence. We will have like max iteration. It limits, runway searching. We turn delegation off because the architecture already assigns the research responsibility. Then we have a content writer. It receives the research artifact. Um, it's not an open web search tool. This is a feature and it prevents, the writer from quietly introducing, some new unreviewed evidence here. Then we have the social editor agent. It receives the article, it adapts it for LinkedIn, X, and returns, the social drafts for us. So you need to think about permissions here. The researcher needs to read access to search, writer, no external tools, social editor needs no social media credentials. And later, publishing component maybe can take care of, really publishing here. Uh, Think about evaluation before you start your design. For example, for researchers, source validity, recency, diversity, claim support. For writer, you can say groundedness, completeness. For social media, fidelity, length, tone, disclaimer, all of these can be, available to us through LLM as a judge and multiple evaluation platforms as well. Um, Now let's talk about the task chain. We have, task one, and it takes the topic and returns research, right? Task two receives that research and returns an article draft. And task three receives the article and returns the social draft. And it's a clean sequential pipeline in this case. So when we have like the phrase that each task only sees what it needs, is both performance and a security principle here. If we have, you asked about cost. So if we have minimal context, we lower token cost, we reduce distraction, and we limit, exposure of sensitive information here. You always need to inspect your chain very carefully. For example, if the social editor receives only the article, it cannot independently verify whether a claim was supported by the original source or not. And so at each boundary, you need to validate after research, check count, required source, after writing, parse the pydantic object, verify its length, after social, enforce some deterministic platform limits, right? You need to have, versioning for your schemas. Maybe at a later time, you want to add citations, right, to your article draft. The older persistent runs should still be, interpretable. So you need to include a schema version or some sort of manage compatibility within your application here. All right. So this is the full architecture. Remember, we are at a system design. So if you immediately go to code, your interviewer will say, what happened to your thought process? So that is why we are going through these slides. I know you are impatient. We will show the code in a little bit. So narrowing, narrating the architecture, user submits a topic through an inference or API, right? And then the application, validates the length, content policy, tenant identity, and then it creates, a run ID for you and invoke the crew. Then the research task calls the search tool through some sort of adapter. The results are normalized, filtered with provenance, right? And then the output is passed forward. We have, writing task consumes the validated research and produces an article draft. And the system parses it, runs deterministic checks, and can optionally run a groundedness evaluator as well. Then the social task consumes the approved article artifact and creates two drafts. All stages emit telemetry to an observability layer. Latency, model, token usage, tool outcome, all of these need to be captured. And at the end, we have, a review gate, right? Not an automated, publish arrow. A reviewer sees the article, social drafts, citations, all of these, and then approval creates a separate command and publish the article. So for scale, you need to place wrong learning work behind the queue, make workers idempotent. API can return the run ID, and then we need to do polling on the status of the task here. There's a lot of, we can discuss the design even more, but let's get to the actual live demo here. Hopefully you can see the code. All right, perfect. So, good. So we will build and examine three agent systems. This is using CrewAI, and here you will learn, how to use CrewAI and what are its different, libraries, capabilities, and functions. There are, as you mentioned, three different kinds of components. We have agents, define who performs the work. We have tasks defining the work contract. And then we have the crew, which defines, the orchestration, which agent and task participate and in what order, right? So usually you are probably used to this. Remember, you need OpenAI key, and some keys are optional. Social webhook URL, for example. And keep your keys in your secret. You will always see a log in your Jupyter notebook. You need to keep your keys in that locked environment. Never share your API keys with others. So first is installing, the libraries needed for CrewAI. You have like commands here, installing CrewAI, and then you do a quick sanity check, making sure that you have those libraries implemented. For example, these are, pretty comments that you can easily find in, Stack Overflow, or even, AI can generate it for you. There you will see, some options. Package name is CrewAI. Tools portion is an extra part. It requests optional dependencies used by CrewAI tool integrations. You upgrades for you, and then you have to import all of those libraries and verify your runtime. So you can see we have a lot of imports. Python, CrewAI, OS gives access to the environment variables. Your API keys are there. Sys exposes interpreter information, for example, version info that you need here. CrewAI is the orchestration framework. CrewAI tools is the companion package that you have. And then Markdown, wraps some generated text in some sort of renderable Markdown page. We need to verify imports immediately rather than wait until the agent code fails, right? Always verification, is important in your environments. So you'll see Python, all CrewAI, all of these already imported here. And then you need to load your API keys. You remember the brain in all of your agents are the large language models. So you need to define like who is your brain here, right? And so you are basically importing getPass. GetPass reads sensitive input without echoing it visibly. It's safer, especially if you have demos. And then here we have, disable the CrewAI tracing because it's a workshop that we want to reduce, the prompts and external reporting in production. Do not turn off, observability. Decide what telemetry is permitted. Redact sensitive content. Then you have the load secret function. You need to check, three sources: existing environment variables, whether you have any user data secret stored in your Google Colab, and, some sort of prompt, but only, for secure secrets that you have. Eventually, you will read all of your environment variables here. OpenAI is required because the selected model provides your brain as large language model. Serper is just optional because search is an enhancement here, and then social webhook URL is also optional because publishing is separate from generation in our case. We just have some sort of, capability based configuration. The system asks, is search available, and adjusts its tool and its instruction. It does not assume that every deployment has, identical credentials. You should never publish or print your secret values because people can misuse your OpenAI key basically. All right, now let's configure the topic and the model and execution setting. Configuration is separated from orchestration logic. We can change the topic or model without editing every agent and task, right? So this makes, experiments easier. One of you asked about the cost, how to experiment with different costs. You need to select a model name. You need to see if you want to, let me get to the code here. Here we have chosen, OpenAI GPT-4o mini. Supports the environment, support an environment override. Always have a default in place. Model choice influences your quality, latency, the price, the context capacity. Enable web search derives, from whether the search credentials exist or not. It's convenient, but production systems may also require an explicit policy here, right? For example, Canvas search policy. Then we have, we can have auto publish. We are setting it to false. It's not used to publish to anywhere in the current notebook, and it is intentional. And then you will define, some of the paths for your outputs for the sake of keeping track of all of the artifacts that we are generating. Can we use this architecture for a different topic? Yes, but, just changing, the topic, which is agentic analytics for data analysis, may not guarantee domain fitness, for example, medical, legal, financial, right? But we can use the architecture here. Next, you need to define your schemas, tools, and whether you have any helper functions, right? And so this is kind of like the densest kind of library set that we have here. It combines structural data, prompt formatting, HTTP integration, CrewAI abstractions, all of these. So some standard and utility libraries, you need, JSON, right? Because our artifact is JSON, output structures are Pydantic objects. You need text wrap, removes common, indentation for multiple strings, etc. Request is used for HTTP client. Maybe if you have a webhook helper, you need that request. We need to have retry policy in an agentic in a productionalized system. Pydantic, defines typed, validated data contracts. For example, the article draft needs to have title, summary, markdown body. Social media draft contains LinkedIn text, X text, publishing status. And what else? You need base model from Pydantic, supplies parsing and validation. And then, we get to the all of our functions, basically all of our tools here. So for example, you have article draft and social draft. You can see both of them are of the type of base model. It's basically, you can see the schema. We have title, we have summary, We have article markdown. Remember, these descriptions are really important. The article body in the markdown. The social graph has LinkedIn X, publishing status, and the description. So these are, the two artifacts that we keep passing among our sub agents. And then we have, build research tool function, which returns a list containing the search tool only, when both the capability flag and environment variable are active. You can see there are a bunch of checks here. And then we have the webhook helper, published to webhook, demonstrates, side affecting integration. It reads the URL at execution time, opens an image, for example, with a context manager, sends form data. The function is not, attached to as an agent tool. This is a good safety property. An LLM cannot decide to publish. Only explicit, Python in the final manual cell can call it, right? So these are, our publishing tools here. We don't have any research tools just yet. And it is, just optional in our case. Now we get to the part that you will probably really like, which is basically creating the agents. We create, we have a base LLM and we have a creative LLM. You can see the temperatures are different. For base, it's 0.2. For creative, is 0.6. Temperature influences your sampling variability. Lower setting is for evidence base, higher setting for variation in writing. You can see how we need, two different configurations here. Then we will have, a researcher goal here. It changes depending on tool availability, if tools are available, with search requesting current source bag insights. Without search, it requests useful insights, with some sort of freshness limitation. Then each agent has, you can see the 3 agents are defined here, but each agent has several important fields. One of them is role. It names, the responsibility. It helps frame the behavior. Goal defines the outcome the agent should optimize for. It should be narrow. It should be testable. Backstory provides behavioral context and style. You can treat it as some sort of soft guidance. It's not a security mandatory. And tool defines the capabilities. For example, only the researcher agent here receives, the researcher tools in this case. The other ones don't have any tool available to them. Allow delegation is false. We prevent hidden subtask delegation. The workflow already explicitly decomposed. Delegation would create some sort of unpredictability for us. We set verbose to true, producing detailed log, useful in the workshop, max iteration, how many reasoning action iterations an agent might take, for example, 6, 8, 6 in this case. And then, we have to go and define the chain and handoff. So that is basically the next step. This is usually defined as a workflow, right? The cell transforms, these 3 independent agents into workflow. The researcher task has 2 prompt variants with search and without search tools. This is kind of like honest, degraded behavior, although, model only search should not be described as verified research. You will have, a task description, right? And that basically research description here with and without research tools are defined here. And this task description contains detailed instructions. What is the expected output in each of these cases? And who is the agent in this case? Should we have markdown or not? And then we will have, so you can see these are defined using task, which is what we imported as part of, CrewAI. And then we have, the article task. You can see it has even more comprehensive description, what it should return, all of those social tasks, LinkedIn post to 2 to 4 sentences, exposed, etc. And then tasks are created successfully here. We rely on CrewAI's task execution and structured parsing in this case. After that, we run the crew and inspect the outputs basically in this case. So here is your crew economic growth demo. Your agents are fed here, researcher, writer, social agent. Your tasks are fed here. And we will say that this process is sequential. And then we will print, we will have some print statements. We will have some fallback instructions, and saving the notes are important. We said we will keep the artifacts all the time, getting the structured outputs when they are available, and stripping down the comments, making sure that they are they are fitted to the right format in this case. So you can see here is the output. Starting CrewAI, new version is available. First it says upgrade, and then crew execution started. Remember, every transaction that you will have has its own ID for the observability in this case. So task started, name, research the topic, agent analytics. Do not invent URLs. These are all the instructions that we gave to our agent. Then the agent keeps starting. We selected different, it actually spits out different colors for you. Agent started, here is the current date, and then agent's final answer. So it generated some answers for you with 5 articles. We specifically said 5, so you can see it's 5. And then task is completed. Good, task is completed. Then the next task is going to get started here. Turn the research notes into a structured artifact graph. This is your writer who has the higher temperature model in this case. Agent started with the instructions and it is generating a whole artifact. You can see it's fairly long, and then it says it is completed. Great. Then the next task starts here, LinkedIn post, generating social media, and then here is its final answer. It generates a LinkedIn post and an X post for you here, a LinkedIn post and an X post, and it says now we have completed our tasks. Great. Here is the result, and it also generates research notes for you. We say we disable tracing, but once you enable, you can see all of the MD files. Here are some of the MD files. You can see that it is in a readable markdown that we used in the beginning. We imported in the beginning of the Python script. So you can see the schema is as we expected it. Social drafts, LinkedIn, X or Twitter, all of these are generated here. And then we will have a manual publishing section, which is easy. We have the text, we just call the webhook URL, and then we will do the manual publishing. In this case of the demo, we have disabled it in this case. All right, so that was the code for the demo. I do want to basically just go back and then talk a little bit about the multi-agent landscape here. We have multiple frameworks. We have CrewAI, which you saw. It's role-based crews, quick expression of agents and tasks. We have LangGraph. We have a stateful graphs. It is kind of like attractive when you need conditional branches, loops, checkpoints. AutoGen emphasizes conversational and collaboration and has been used for multi-agent discussions. It can fit, exploratory, dialogue-oriented workflows. And then OpenAI Swarm, it's basically a lightweight experimental, handoff framework. You can treat it as that as some sort of like historical context framework. Ecosystem moves quickly, so Swarm is kind of like used for educational and experimentation at this point. Here's a good table for you to decide, between these frameworks. You need to have like a decision process with concrete questions. Do we need dynamic branching or mostly sequential? Must runs pause and resume later? Do we need, human approval in the middle? What observability and evaluation hook exists, right? My quick guidance is that choose CrewAI for a readable role-based crew. Choose graph approach for explicit conditional state. Conversation-oriented tooling for just conversational collaborations, and then plain code or a workflow engine when the process is already deterministic here. So the best framework is one that makes important behaviors explicit and testable. Remember, testability is really important. So you shouldn't just jump to, stuff that you are not comfortable with. All right. I think I will hand off now.
Yeah. So
Sorry.
before Nahid covers the interview preparation part, I'm going to quickly jump in. I know a lot of you are asking for the link of uh, the collab notebook. We are going to, I'm just sorting out the access for it, and as soon as that is done, I'll inform you. If it's not done while I'm trying to present my screen or till we are here, don't worry, it's going to reach your mailbox or can be shared via the program advisors. I'm going to take some time and talk about what a few of you were asking at the start of the session, right? While we are talking in depth, thanks to Nahid, about CrewAI and multi-agent AI systems, what is important to understand is what do you do after this, right? What's the next step? Is the next step to learn different concepts and try to build that in, or have a more structured part? So when I posted that question of that poll in the beginning, almost about 57 to 60% of you said that you lack a structured path to get the AI skills for your role or your domain. Uh, so I can understand that you could either be in these four stages of AI denial. You may feel that AI is moving too fast. Okay, there's so much to cover. Where do I start? What do I do? How many such master classes, do I have to uh, cover so that employers or recruiters or hiring managers start looking at me as somebody who has the right AI skills built on top of the tech stack that you already have, right? A lot of the third box, I think, doesn't exist in the latter half of 2026 anymore. People don't think their job is too unique or safe. Every JD out there requires some level of uh, AI know-how. And the one question that we get from our experienced learners, so most of our learners have about 8+ years of experience. So we deal with mid-senior to senior to leadership level of candidates. So they say that I don't want to down level. I have spent, say, 10 years building this tech stack. You can't ask me to start from scratch. We don't actually. That's why our customizations come in play. So AI curve as such has moved on from just increasing your productivity via using LLMs and copilots to about 55 to 70%, depending on which domain you're in. 55 to 70% of job descriptions now ask for agentic AI or generative AI skills, right? And that's the transformation leg of the AI curve. And that's where we enter. So we know you have aced the augmentation and productivity, increasing productivity part, but we help you signal to recruiters and hiring managers out there that you have the right AI skills with the domain expertise that you bring in, which you have done for, developed over the last few years. So for that, we have three programs. The first is, and it says very rightly here, if you're unsure of what I need to do, this is like the base that you should have, you must have. And I believe me, I am not trying to push it by saying must have. I'm doing this because my job for the last in the 12 years that I've worked, the last 5 years has only been about talking to various tech hiring companies, top tech companies, and trying to understand what do they require, what are they looking for in their candidates, and bringing all of that information to you. We can talk about this more through our program advisors. Feel free to talk to them. They will anyway call you after the session. But Transformative Gen AI and Agentic AI plus Interview Lab program is something that takes you from advanced to beginner to advanced level of generative AI and agentic AI, right? It has three versions: pro code, low code, and no code, depending on the proficiency of coding that you have. And you also have 18 different customizations that you can make to the AI up leveling part as well as the interview preparation part. Okay. We give you 15 mock interviews with hiring managers in Mank Plus companies who are nobody else but our instructors, who are actually hiring people like you or sitting in panels which are hiring people like you. And these are live mock interviews where you get direct feedback there and then, right? We also have a project-based learning path that we provide to you. And that brings me to our second program, which is with in collaboration with PwC India. Now, this is for people who have certain level of AI skills already. I asked a second question in the poll that how many of you already build AI agents or multi-agent systems, right? And some of you said, not a lot of you, but some of you said, for you guys, this program is about just building industry grade, enterprise grade portfolio through capstone projects across these four industries: healthcare, BFSI, e-com, and supply chain, so that you have a portfolio ready to signal it to hiring managers that, hey, I'm not just saying that I have the agentic AI skills that you need. I've also built production ready projects which I can show you. The third program is the newest one. This role itself in India has picked up in the last 3 months. When it started off, there were about a few hundreds of openings, and as of today, there are over 1,000 openings of FD as well as adjacent roles. Some of you might have heard of this role, and somebody asked me in the chat also, what is an FD? An FD is somebody who comes from AI engineering background and sits in the client location and does everything in the client environment, right? But it's not something that was existing. Some of us feel that this was already existing or this is old. But right from understanding the business problem to designing the solution for it, building it yourself, and of course, you're going to have a team of people, but delivering it end to end is what an forward deployed engineering role does, right? And there are, like any other software engineer, SDE 1, 2, 3, there are FD 1, 2, 3, and all of that also. So don't worry, you're not going to do everything on your own, but going to pick exactly what your role requires. So in our program, we cover AI engineering plus FD spine, as well as we prepare you for FD interviews specifically. Again, we cover two capstones over there, and this takes you from, right, like I said, right from discovery to building to deployment to helping the customer adopt and scale that solution. The 18 customizations that we have are right in front of you. Right from backend engineering to SRE DevOps to management roles like EM, which are tech leaders, product managers, TPMs, etc. What does our interview preparation or interview lab entail? We cover DSA and system design in detail live, as well as we give you your domain specific interview preparation, right? So whichever domain you're from, we give you preparation as per that. Then we also give you mock interviews, like I said, with our Mang Plus instructors, and the career services that are mentioned on the right: LinkedIn optimization, resume optimization, offer negotiation, etc. We have a network of about 200 plus hiring partners in India. And we also give performance and fitment based referrals once you complete the program successfully through these hiring partner network, as well as our alum network and our instructor network. Okay. So if you have completed the program properly and you're looking for a change, if you fit the profile that we get, we refer you over there. Now, the duration of the programs is in front of you. As I said, the transformative generative AI program. This is for 3 + 3 months program. This is 6 months program. The FD program is also about 6 months. the agentic AI, the PwC program is also 12 weeks plus 3 months. This is the price of each of the programs. So the transformative, generative, and agentic AI plus interview lab is 1.5 to 2.8 lakhs, depending upon the track that you choose or the domain that you choose. We have various financial options available, so everything can be broken down into EMIs. And if you select the right EMI structure, believe me, it will be lesser than your grocery bill that you get every month. And this is an investment that will give you returns not just for a month, for a year, but for many years, right? The second program, which is the PwC India Agentic AI Accelerator and Interview Lab, is between 2 to 2.8 lakhs, again, depending on the track that you come from. And the forward deployed engineering program is for 2.75 lakh. If you're interested in any of these programs, please feel free to talk to us, talk to our advisors, and I'm going to launch a poll to understand if you want to fast track your candidature. Go ahead, select yes over there so that we can call you. If you need more information on all of these programs or any of these programs, we can give that also, so you can select maybe. We have certain scholarships going on, and it is obviously on first come first basis. So go ahead, let me know if we can get in touch with you. And whatever it be, like either this or any other path, do not stop your upskilling journey. That's super important. Nahid, and if you check out Nahid's LinkedIn, you'll see one constant thing across. She never stopped learning, right? And that's what all of our instructors do. And that's become like table stakes nowadays. So go ahead, think about that, and I'll hand it over to Nahid again to take us through the interview preparation part. What questions should we expect for the particular topic that we are covering?
Okay, sounds good. So, basically, we have just a couple of questions that you may get at the interviews. One is, question one, design a multi-agent system for automated content generation, right? So, design, a multi-agent system. Do not begin with, I would use CrewAI and create 3 agents, right? Just, first clarify the system being designed. Ask what content is required. Does it need technical articles? Is it product descriptions? Is it for supporting materials? Ask who the audience is, which channels are targeted, what volume and latency are expected, whether content is generated in batch or interactively. Ask what evidence sources are approved for this search. So first, clarify the requirements, the functional, non-functional requirements, quality bar, languages, regulatory constraints, whether a human must approve the publication or not. Then estimate the scale. For example, 10 internal draft per week needs a different architecture from 10,000 product description per hour, right? Scale affects the queues, your concurrency, model quotas. Many of you ask like how much cost, what should be iteration, what should be, the rate limitation. And the interviewer basically evaluates 4 things here. Can you convert an ambiguous request into requirements? Can you create meaningful responsibility boundaries? Can you explain data flow rather than, drawing some sort of agent bubbles around or not? And basically a strong candidate will answer, I will assume we generate evidence-based articles and social media drafts similar to what we created here. I will begin with sequential researcher, writer, editor, and I will keep orchestration deterministic, etc. And then complete model answer using the 7-part framework. You kept asking, in I saw a couple of Q&As, what should we be our solid framework here? First, clarify. I would identify the content type, the audience, the platform, all of these, whether the system optimizes for speed, for cost, for factuality, or for brand quality. Then decompose. Use a research agent to retrieve and normalize evidence, a writer to produce the structured, a social media draft, for generating the text. And then you have to have, platform adoption. It can be a separate, social editor if it comes trends differ, for LinkedIn versus X versus Instagram. Instagram you need to generate image, video, right? So make sure that you break down the task. Then you need to think about chaining. The input is a validated content, brief with topic, audience, etc. What are the contracts? What is the JSON formatted files that we are passing? We had article draft, we had a social media draft, we had editorial review, right? And then make sure that you stick to these guidelines to avoid hallucination in your model. Then you need to process. The main part is sequential because writing depends on research, editing depends on writing. Independent research queries can fan out in parallel and then merge, right? Workflow or deterministic orchestrator, it owns the state, retries, budgets, cancellation, and we will usually use an LLM manager only if task decomposition is unknown, right? But here, even a human, like if you think about human process, the process. So if it's not in non-deterministic, go with the sequential. You have to have guardrails, use type schemas, deterministic validation, and restrict agents to least privileges tools, require citations for facts. Then you need to think about productionalization, place requests on a queue for asynchronous workers, persist version artifacts, record latency, token usage, pair each of your models, pair agent, and use idempotency keys for side effect to avoid duplicate searches, duplicate text generation. And you need to also explain the trade-offs that you will have. More agents can improve specialization and evaluation, but at the same time, they will increase the latency, the cost, and the failure surfaces here. So after that, you will be ready to go over your architecture here. All right, so another question, is your multi-agent pipeline produces inconsistent results, debug and fix it, right? So basically, first, you need to identify and define the inconsistency, localize it, two-stage using some sort of run level traces, frozen failing cases, changing one variable at a time, validate the fix against a regression test, right? So, you cannot just quickly jump and say, oh, I'm going to do these different tasks, right? You need to have a structure for your agent debugging, and that completely depends on the system that you have designed in here. There is also like a debugging, principle. First, you need to instrument, assign every workflow a run ID, right? You saw we had unique hash IDs. Every task has an attempt ID. We record all of these for the sake of validation at a later time. Then you isolate, select, representative failing run, compare them, with passing run, see what is different in these cases, diagnose from, hypothesis to evidence. Common causes can be like ambiguous task instruction, conflicting prompt, excessive temperature, changing tool data, context truncation. There are multiple, reasons for a failing agent. You need to diagnose which is the reason and then try to fix it. Make the smallest change possible and then run again through your passing test and your failing test. Finally, validate, run the fix against the frozen regression suit, normal, edge adversarial, previously failing cases, and compare it with the baseline of the same rubric. Measurement and evals, track task success rate, schema compliance, citation validity, and then always prevent, right? Put prompts, schemas, contracts in place, run regression evaluations as part of your CI/CD pipeline, use canary or shadow releases, monitor the quality of your operational thresholds, and then that will really give you, a working diagnosis here. All right, so I would want to, kind of like just have a quick takeaway here. First of all, specialize, do not, fragment. Give each agent one coherent responsibility, but do not create extra agents without a measurable reason. Second, the task chain is the real engineering work. Define inputs, outputs, provenance, validation, retries, and agent personas are easy, but dependable handoff are really difficult. Have structured outputs, schemas, make artifacts parsable and testable. Add semantic evaluation. Valid JSON can still contain false claims, right? And finally, separate generation from action. A draft, recommendation, proposed tool call is not authorization. You need to have policy checks and human approval in front of, consequential events here. I would kind of like also add a fifth takeaway is my personal favorite. Evaluate before you automate. Build a representative test set, establish a baseline, measure each stage, and without evaluation, changes to prompts, models, or frameworks are just guesswork, right? And one final thing, prefer the least autonomous system that works. Deterministic code, we always want to jump on the hype and like build this complicated system, but deterministic code for known workflows, models for, ambiguous judgments, and then kind of like narrow tools for interaction with the world is the strong, production default. You want to be able to productionalize your model. And finally, thank you so much for your attention and for your time. I have tried to answer almost all questions, but I'll check the Q&A again.
Mostly all questions are answered, Nahid. There were
Mhm.
some questions on the collab notebook that you were sharing. We had some access issues. We have tried to sort it out and put it in the chat.
Okay.
Guys, you can have a look and see if you're able to download from there. Like I said,
Mhm.
if you can't, don't worry. Don't fret over it. We will share it via email anyway. And your program advisor who's going to get in touch with you after the session is also going to is going to help you with that. So don't worry about that. But I think we've covered mostly everything. There were questions around examples of LangGraph, AutoGen. I think you covered those anyway. Kyla
Awesome.
Rathod had some question on the program. I've answered them. Kyla, if you still have certain questions regarding the program, feel free to just block the calendar of our senior program advisor. I've shared the link in the message with you. Yeah. Now, if you want to take up any question you feel that you have not answered something, feel free to do that, or else we can call it a night.
Um, I think that's about it. There's only one question. Does CrewAgent have all the connectors to connect with internal tools?
Yeah.
Um, It depends. There are some third party, like many companies, CrewAI is well adopted, so there are a lot of availabilities. But you have to check, their yeah. So for example, I don't specifically know if it can use Outlook or not, or I know they have an Office 365 suite, but I haven't personally checked Outlook. Or for example, I don't know if they have a Slack, but it is very well adopted in the industry, and they probably have available tools. I think that is the only technical
Yeah.
question remained.
Correct.
Thank you so much.
I've answered most of it in my sure.
Perfect.
Thanks again, Nahid. Thanks for joining in.
Yeah,
I know you have a whole day ahead of you, so happy
absolutely.
Thursday for
Thank
you.
you. Yeah,
Thank
thank
you.
you.
Take
Nice to
care.
meet
Thanks,
everyone. Bye.
everyone. Bye.